What is destination-based forwarding? In traditional routing that uses destination-based forwarding, the only parameter deciding which output port to use to send out a packet is the destination of the packet. This destination will be consulted against the forwarding table at the router. The forwarding table, in this case, will include the range of destination addresses and the corresponding port that tells which port the packet should use to go out to reach the desired destination. Back to our driving example, this would be similar to deciding which turn to take in an intersection on the path based on the destination address only. So, for example, in the table shown in the figure, if the destination address is within the range of addresses depicted in the first row, the packet will use the outgoing port 0. If the destination address is in the second row, it will use the outgoing port 1. If within the third row, it will use the outgoing port 2. And if it is not within any of the given ranges in the previous rows of the table, it will use default path for all other destinations, which is the outgoing port 3, depicted by otherwise in the last row. In this table, the ranges have been selected so nicely, dividing the range covered by the last 2 bytes. What happens if ranges do not divide up nicely? This actually happens quite a lot, as the ports are facing networks with different ranges of supported addresses. What is used in traditional destination-based forwarding tables is longest prefix matching. In longest prefix matching, when checking the destination address of a packet against the forwarding table entries, we look for the entry with the longest specified address that matches with the most number of bits with the target address. The table in this case will include entries with variable lengths of a specification, with unspecified bits shown in asterisks in the figure, determining the address coverage ranges. For example, if we have a destination address with the last 16 bits of 0001, 0110, 1010, 0001, as in the first address in the examples, we will use output port 0, as it matches with the most number of bits with the first row. The second number in the example, though, would match with both of the second and third row entries. However, since it has the longest match with the second row, it will use output port 1.